Hello there, this is Thomas from investmentexcel.com. Today I will show you how to take advantage of vector and matrix notation when it comes to building multiple regression models. Particularly we will look at a model where the stock price of Amazon Incorporated is described by a true model including two explanatory variables, being the GDP in the US, the GDP level, and the level of the 10-year US Treasury bond. Please refer to other sessions I have made that are more simple if you're not too familiar with multiple regression analysis. This video and the Excel workbook are available on investmentexcel.com and spotify.com. Alright, let's start out by looking at a time series being the sample. And we have it here, 25 observations of the price of Amazon. Never mind the level of the Amazon share. I guess the model doesn't care really. And here likewise 25 observations of the level of GDP. So you could interpret this as a dollar value, $200 US of GDP on an annual basis. This is simply the price of a 10-year US Treasury. Alright, now I would like to build a model where the ultimate goal, of course, is to predict the Amazon price from the model. As always with cross-sectional models like this one, we need ultimately also to predict the GDP and the 10-year bond if we want to predict the Amazon price. But the idea about the estimation is to get a functional relationship on which we can use the predictions of the explanatory variables. The general model, not only for a case like this with two explanatory variables, also with one explanatory variables, that is the simple linear regression, and many more variables, is like this. So you have a true model, a population model of y, the endogenous variable, in this case the Amazon price, being described by a linear relationship and a stochastic expression, the normal distributed expression encapsulated in the error term. The way that this has to be looked at in terms of matrix and vector notation is this. On the left hand side we have a n times 1 vector, so in this case 25 times 1 of Amazon prices. On the first expression on the right hand side of the equality sign we have x, and x is a matrix with the explanatory time series and one more, which is a unit vector that takes into account that we need ultimately to have a constant term in the regression as well. So the dimension of the x is n times k, where k is the number of explanatory variables, 2 plus 1, so 25 times 3, and we multiply this with a vector 3 times 1, which is a vector of parameters for the intercept, that is just the constant, so the parameter is equal to the intercept, and then there's the parameters in front of the GDP and in front of the US bond. This is a true model that we would like to estimate, and estimating this with the ordinary least squares, we will get this equation, and you see that the random noise has dropped out because of its distribution with an expected value of 0. So it drops out in the estimation, because the equation that we really estimate is the expected y. So when you take expectations to this expression, you'll see that the noise goes out, and when we minimize the squared residuals, which is the idea in the ordinary least squares, yes, we get this expression. So the free parameter estimates can be explained by the X matrix and the Y vector. We just have to do a little bit of transposing and inversing. Let's see what we will end up with. Let's start by calculating the first expression within the parenthesis, X transpose times X. This is a matrix with a dimension of 3 times 25 multiplied by a dimension of 25 times 3. So it will be a 3 times 3 matrix. This is what I have lined up for here. So just show you how to do that in Excel. mult, and we need to transpose the first X matrix like this, and we will multiply it with X like this. So in order to expand the matrix, hold down Shift on the cell that has been calculated initially, and mark the rest of the area. Type in top, hold down Control Shift Enter. Here we'll just make the inverse of this relationship. I'll do exactly the same. Mark, it's a 3 times 3 as well. Every time you inverse a matrix, it has the same dimension, otherwise it could not be inversed. So on the last one, the right hand side, X transpose times Y, it's a 3 times 25 times 25 times 3. It's also a 3 times 3. No, it's not. Sorry, it's a 3 times 1. 3 times 25 times 25 times 1 is 3 times 1. mult of xt transpose this one and calculate, multiply it with the Amazon price. Let's see if it was a 3 times 1. It was. So now I have the 3 major parts in the estimation formula. I will now try to insert it here, and remember, it's the way the way the vector is built is with the beta 0, the intercept first, and then beta 1, and then beta 2. When I multiply these three expressions, I have a 3 times 3 vector. So let's just try mmult. Start by this one. Oh, sorry. No reason to do the inverse when we have done it already. So I'll just multiply 3 times 3 with 3, 1. That's the 3, 1 vector. And let's see. Okay. So this was the relationship, and I'll just take a look out here if that was correct. It looks so. Okay, not 100%. 969. Okay, I have probably typed in a number somewhere. Okay, but this is the way to do it. But we can, so what we see is the intercept is minus 608. Never mind the implication. GDP estimate 3.37 on the parameter and 9.13 on the 10-year bond. We can double check the result, and then I'll find out if this is correct or the one that I did in the rehearsal. It's probably the rehearsal result that's correct, but I'll just have Excel calculating the result, and I can do that in regression analysis. Type in the y, and then I have to again type in no, hold on. So see. Okay, so here we got the results. Let's see. I'll just copy paste. Minus 608. Okay, so it was correct. So difference obviously being because I just changed somewhat one of the inputs. So this was correct. So please note that when you use the Excel built-in function, we don't need to put in the intercept. Excel does that on itself. Excel calculates by the matrix system also, but it adds the unity vector itself, so you don't have to put it in. So this is the way to estimate parameters with matrix and vector notation. Thank you.